Good morning, students. So, we came to our last week of our HVAC online class. Today, it's our day 16 of our HVAC online class. So, we'll be closing this HVAC class by this week. So, we have some more portions to take. Okay. So, and last day's HVAC day 15 recording I have already sent to your mail today morning. So kindly go through that. Okay. So uh, not only that, our new batch HVAC as well as electrical new batch will be starting on next Monday. So if there is some friends of you who can just if you can intimate like there is a class like this HVAC and electrical online class, I would really appreciate that if you send the brochures or the flyers. Okay, I will be sending to you personally also. So if you could forward to your friends or some friend circles or college circles, that would be better. Okay. So I really appreciate if you send brochures or as well as the flyers. Okay. So thank you. So last day we were dealing with softwares. We have already completed HAP software, then Beta software for air terminal sizing. We have seen sound attenuator software for calculation of sound attenuator. That checker software we have seen. So last day, those who are absent, you can go to your the video that I have already sent you by mail. So go through it, and I think 3 or 4 softwares I have taken on the last day. Okay. So today we are going to deal with another topic, that is estimation and costing. That is one topic, and another one is cold storage design. Okay. So these are the two topics that I would like to take today. So we can initially we can go and deal with the topic cold storage design. Okay. Actually, what do you mean by this cold storage or cold room is that if you need to preserve food, okay, some food items, if you need to preserve it, mainly we'll be keeping and storing inside a cold storage. Okay, or sometimes we could call it a small cold storage, sometimes we could call it as freezer. Okay, we do have different items which can be stored inside it. One can be fruits, it can be vegetables, it can be meat, it can be milk, it can be another dry fruits. Okay, why we need to store this in order to preserve it, in order to preserve even for months, sometimes some materials for years, we could store it. So basically, we have cold storage. Cold storage. Okay. Sometimes we calling it as big cold storage as warehouses also. Okay. So we are going to see, or we are going to see an example of how to calculate its capacity or the cooling capacity. Okay, how many tons of capacity that we have to calculate for a particular item. Okay, that can be vegetables, it can be fruits, it can be meat, it can be milk, whatever it might be. So I will give you a small example today, only that much. We'll be doing it manually. Manually in the sense, we'll be calculating it manually, and we'll be seeing different graphs. We'll be taking different tabular columns and taking different graphs. According to that, we could calculate what will be the capacity of the cold storage. Okay. Not only that, we will be using, not we, usually we have softwares also for calculation of this cold storage. And for taking this software, and if you want, you can go to the Google, and there is a free software in which you can calculate it, and the manufacturer which gives that software is Danfoss. Okay, you can go to the Danfoss site, DANFOSS it seems, and you could download uh, its software free. Okay, and if you go to YouTube, you can find it out how to calculate it. It's very simple. Okay, just give its value, and you could get its capacity in kilowatts. Okay, or in ton. You can convert it. Okay. So today we will be dealing with its manual calculation. So you could write HVAC class day 16 and today's date, and you can write what is cold storage inside. You could write the heading cold storage inside. So I will share my screen initially. Okay. So you could write that cold storage design. Okay. So initially I will explain what is a cold room, and from there on this heat is being, it's been generated. It is similar to that what we have calculated for HAP as well as for P2B and OGEN. The main, aim what we are using everywhere is that from where and all the heat is being produced, or from where and all the heat is being generated, and we'll be calculating the amount, okay, of the heat from different items. Even it can be the product, even it can be some equipments, okay, even it can be the wall, roof, floor, etc. And we'll be calculating it, we'll be adding it, okay, and we'll be converting that amount of heat in BTU per hour to ton value. That's the usual general method, but we will be using for heat load calculation. So here also, to calculate the amount of the capacity for a cold room or a cold storage, what we use is that we'll be finding out the heat generated or heat evolved from a particular items, okay, and we'll be adding it, and we'll be finding its so initially I will discuss what is this cold room, right? So what is a cold room? Okay, a cold room is used to store perishable goods. Usually, our food items will be perished after some days, right? Okay, so why we are using this cold room is to preserve it or to store these perishable goods such as meats and vegetables. It can be meats, vegetables, whatever it may be, dry fruits or meat or milk or whatever it can. It can be any material that we need to preserve it. A cold room is used to store perishable goods such as meat and vegetables to slow down their deterioration. Okay, this deterioration means they will be perishing easily. So we have to slow down its deterioration time so that we can preserve it for long time. Okay, that is our aim. Okay, this is mainly happens due to the heat which is generated. Because of the heat only, this items will be perishing fast. Okay, so what we are doing is that we are slowing down the deterioration time of an item. Okay, so to slow down their deterioration and preserve them as fresh as possible or as long as possible. We have to keep it fresh, and we have to store as long as possible. For example, in your home, refrigerator, fridge. Okay, it is also a cold room or a cold storage. We can call it. Inside that there is a freezer. That is also a cold storage. So you could preserve it. You could buy your fish or meat or whatever it can be, and you could open your freezer inside your fridge, and you can keep it there for some weeks, right? You'll be bringing the fish or meat, and you'll be preserving it, right? So what we are doing is that we are slow down its deterioration, and we are preserving them as fresh as possible for a longer time. Okay, so what helps in this deterioration? So heat accelerates their deterioration. So the products are cooled down by removing the heat. So the main criteria which the food gets perished or deteriorated is due to the heat. So what we are going to do is that we are going to treat the heat, or which means that we are going to remove the heat. For removing the heat, what we need air conditioning. Air conditioning coolness or coldness. Okay. So heat accelerates the deterioration, so the products are cooled down by removing the heat. So what we are trying here in the cold storage is that we are removing the heat. Understood? So if you want to remove the heat, first thing is that we need to know from where and all this heat is being generated. That is what we are going to find it out. Understood? From where and all the heat is being generated, that we will be going to find it out, and we will be getting its amount in BTU per hour. Okay, then we will be adding all the BTU per hour, and that BTU per hour will be converted into TR. So that much heat has to be removed. So that much heat has to be removed means that much conditioned air or the cool air should be given to that particular space. Understood? So similar to what we have calculated in the heat load calculation, the same thing. To remove the heat, we use refrigeration system. So this allows accurate and automatic control of the temperature to preserve the goods for as long as possible. So here what we are doing is that we are removing the heat. So to remove the heat, we need to know what the cooling load will be. Understood? So to remove the heat, we need to know what will be the cooling load. Okay. So the cooling load varies throughout the day. So in most cases, the average cooling load is calculated and the refrigeration capacity is calculated to suit this. So we need that we have to remove its heat, right? Which means that we need to give the cooling load. The cooling load will be varying depending upon the day. So morning it will be different, afternoon it will be different, evening it will be different. So we need to know the cooling load. But but the other thing is that the cooling load will be varying, okay, throughout the day. So what we do is that we will be taking its average cooling load. We are going to calculate its average cooling load, okay, and its refrigeration capacity is being calculated. Understood? So these are all are different basic things. You can read it and you can understand. So now we are going to do from where does all the heat come from, so that we can remove the heat. So we are going to see, the second thing that we are going to see is that first thing we have studied that because of the items get perished or deteriorated. So the second thing, we have found out that we need to remove the heat so that we can give refrigeration. Okay. And the third thing is that what we are going to do is that we are going to find from where and all this heat is still coming. Then only we'll be able to remove it, right? So the third thing that we are going to see is that from where and all this heat is being generated, that we need to know. Then only we'll be able to treat it. Right. So the thing is that the cold room heat sources. Okay, the cold room heat source. Okay. So in HVAC and all, we have already studied and we have already studied about the heat is being generated from people, from equipments, from walls, from floor, from ceiling, from roof. Okay, different items the heat will be generated. The same way here also we are going to find from where and all the heat is being evolved or what is the heat source, so that we can remove it. Understood? So it is said that it has been found out that typically 5 to 15% is through the transmission load. Transmission load. What do you mean by transmission load? We have already studied. So this is the thermal energy transferred through the roof, walls, and floor in the cold room. Okay. Heat always flows from the hot to cold, as you know. And the interior of the cold room is obviously a lot colder, right, than its surrounding. So heat is always trying to enter the space because of the difference in the temperature. So you know that outside temperature is comparatively warm comparing to the inside the cold room, right? So what happens is that the outside temperature obviously have a tendency to come inside because it transfers from hot to cold, right? So heat is always trying to enter the space because of the difference in the temperature. Okay. So if the cold store is exposed to direct sunlight, then the heat will transfer will be higher. So an additional correction will be needed to apply to allow for this. So 5 to 15% is through the transmission load. So you now understand about that. Okay, from the wall, roof, should be transmitted through this. Okay. The second one is when we have the product load. That is the very important thing. What is the product that we are storing? From that product, lot of heat will be generated. Some days we'll be storing meat, some days we'll be storing fish, some days storing vegetables, fruits, whatever it might be. So it has been calculated that when we have product load, so we will be storing even tons, okay, tons of products. So when we have product load, which account for typically 55 to 75% of the cooling load. So see this, 55 to 75% of the heat is being produced from the products that we are going to store. So this accounts for the heat that is introduced into the cold room when new products enter. So sometimes the products will be keeping it, they'll be taking it off again, another product will be coming, the same product will be coming, okay, will be circulating, right? So this accounts for the heat that is introduced into the cold room when new products enter. It's also the energy required to cool, freeze, and further cool after freezing. So we have different levels. We can cool it. We can freeze it. We can we can further freeze. Even it will be going even to, we can cool it at 0 degree or 2 degree, 5 degree, like that. Okay. So for every items we don't want to cool it at 0 degree, right? For some items we need 5 degree, 10 degree. That's might be enough. For some items it can be 0 degree. For some items it can go to even to negative. For some materials like meat or something like that, we have to set the temperature even to negative. So it's also the energy required to cool. Okay, we can cool it, we can freeze it, or further cool after freezing. Okay, so there is a different levels according to different items. Okay, so if you are just cooling the product, then you only need to consider the sensible heat load. Okay, sensible heat load, you know that there is no a phase change, right? There is no phase change, only sensible heat. So if you just need to cool, you need to calculate or consider only the sensible heat. So you know what is sensible heat and what is latent heat. Sensible heat means I already said that you can sense it and there is no phase change. But in the latent heat, there is a phase change. Okay, the water will be changed to ice. Okay, or ice will be changed to vapor. There will be a phase change in the latent heat. So when you are deciding only to cool something, okay, only to cool something, we just need to consider only the sensible heat load. Okay, if you are freezing the product, then you need to account for the latent heat also, because there is a phase change. Understood what I'm saying? There is a phase change. So okay, so during this time, the energy used during this time, energy is used, but you will not see a temperature change while the product changes between the state of liquid and ice. Okay, because of the latent heat. There is an additional energy required to further chill this food. Okay, you need further energy. Okay, additional energy required to further chill this food down below the freezing point, which is again sensible heat. Now it will be coming again sensible heat. Why? Because there is no latent, because there is no phase change. So in order to convert the liquid into ice, there is a phase change. Again, so it becomes freezing point. Again, if you are further freezing, ice will remain ice itself only. There is no phase change. So what we need, again, we need to calculate only the sensible heat. So the thing is that if you need to calculate or if you need to find out a cooling, you need to find out only sensible. Okay. Then if you want to freeze it, you have to calculate the latent heat also, because the phase is changed. Again, further if you need to freeze, but still we need only sensible heat. Why? Because again, if you are further freezing, the phase is not changing. Okay? It is staying in ice form. So you also need to account for the packaging as this will inherently be cooled also. So you will be consider our packaging also. Okay. Lastly, if you are cooling fruits and vegetables, then these products are alive. Okay, and they will generate some heat. So you will need to account for the removal of these two. So you have to consider the packing of it. Then another one important thing that you have to consider in your mind is that when you are storing some fruits and vegetables, the fruits and vegetables are live things. They are alive. Okay, so when because of this alive, they produce lot of heat. Okay, so when we are dealing with fruits and vegetables, we'll be considering one separate item known as respiration load. Okay, respiration load. Okay, respiration load means because some items are alive. Okay, there is a respiration load, we have to find it out, because we know that what is respiration. We'll breathe in oxygen and we'll be breathing out carbon dioxide. So when because of this, there is a chemical chemical reaction which takes place, and some water and all some other other items will be generated. Okay, so to convert this thing, so to convert the actual product into this water and all those chemical reactions which will be occurring in this live food, heat also will be generated according to that. Okay, this will take place only in live foods. Okay, only in alive foods. Alive foods means only in vegetables and fruits, because they are alive. Because of this respiration law, heat will be evolved from that. Okay, so if another items like milk or dead items like meat or fish, there won't be any respiration loss because they are not alive. Okay. So in cases of vegetables and fruits, you have to calculate the respiration load also. Okay. Now the next thing is to be considered is the internal load, which will account for around 10 to 20%. What is that? Internal loads. What is an internal load? This is the heat given off by people working in the cold room. So don't think that the cold room is a very small freezer. It can be a big room also. It can be a big room. Okay. So people will be working inside that also. Okay. So this is the heat given off by people working in the cold room. The lighting and equipment such as forklifts, trucks. So sometimes forklifts will be there for keeping the items in a particular rack and all. Some trucks will be inside, forklifts will be inside. So all these are equipments. Okay. So the heat is given off by people working in the cold rooms, the lighting and the equipment such as forklifts, trucks, etc. So for this, you will need to consider what equipment will be used by the staff members in order to remove the products in and out the store. So we need to know what type of equipments these people who is working inside the cold room are using it. According to that, you have to calculate the heat generated. Okay, how much heat will they and the equipment will give off and the daily duration also. So this is nothing but we are considering from where all this heat is being generated by people, by equipments, by lighting. Okay, all these things will be getting 10 to 20% will be involved from that. So then we need to consider the refrigeration equipment in the room, which will account for around 1 to 10% of the cooling load. What is that refrigeration equipment? For this, we want to know the rating of the fan motors and estimate how long they will run for each day. They want to account for any heat transfer into the space from defrosting the evaporator. So this is the heat which is produced from the refrigeration equipment itself, from the air conditioner equipment itself. Okay, you know there is a fan and a blower and evaporator and all those things. Okay, that will be kept inside it. But there also heat will be produced. So that also we have to take it into account. So the last thing we need to consider is infiltration, which again adds 1 to 10% of the cooling load. You know already what is infiltration, right? So this occurs when the door opens. So there is a transfer of heat into the space through the air. So outside air can come inside through infiltration. Sometimes when the door opens, okay, there will be door in the cold storage, big warehouses. So each time when you open it, there is a chance of infiltration of the air from the outside to the inside. Okay. The other consideration is ventilation. Okay. Fruit and vegetables give off carbon dioxide. So some stores will require a ventilation fan. Yes, sometimes they need some ventilation fan also because the fruits and vegetables gives out carbon dioxide and people will be staying inside and working inside so that they will be affecting it. So sometimes we need to give a ventilation fan also inside the cold storage room. This air needs to be cooled down, so you must account for this also. So, you know, when we are giving ventilation, sometimes the outside air will be coming inside, so that also has to be cooled. So all these things has to be taken care. Okay, so the 5 to 15% through transmission load, 55 to 75% of cooling load or the product load, then the internal load 10 to 20%, then the equipment, actual refrigeration equipment load 1 to 10%, then infiltration and ventilation 1 to 10%. So these are the things that we have to consider. So what you have to do is that what is the cold room that you don't want to write. So just write cold room heat sources, and you can write the black points, the main points. The rest you can go through the video that I will be sending you later, and you can go through and you can study. For the time being, I want you to write where does all the heat come from and that we need to remove. So you can write these points, how many percentage that we need. So you can write it or note it down on your notebook. Once you finish, let me know. Just you write only the main points, okay, which I have written in black. After this, we'll be going and to find out a or going to solve a problem. Have you finished writing this too? What about others? Have you finished writing? Okay, next one. Write this point also, okay? Transmission load. Internal load, 10 to 20%. Internal loads which account for around 10 to 20%. Next one is refrigeration equipment, 1 to 10%. Okay. The last, infiltration and ventilation or infiltration. Okay. So I believe you have completed this. So now we are going to do a or solve a problem, okay, regarding the cold storage. So write this question, okay. You have to solve this with me, okay. Find out the capacity of the cold storage shown in the figure that I will show you. Product to be stored is 2,000 pounds of milk per day. The product is 2,000 pounds, okay, 2,000 pounds of milk per day, and we need to find the cold storage capacity. So this is the question. Find out the capacity of cold storage shown in the figure. Product to be stored is 2,000 pounds of milk per day. So the product that we are going to store inside the cold storage is 2,000 pounds of milk per day, and we are going to find out the cold storage capacity. So what should be our cold storage capacity? Okay, if we are storing a milk of 2,000 pounds per day. Okay, have you written this? Now, so here we are just only cooling. Okay, we are only cooling. We are not freezing it. We are because you know, we are dealing with milk, right? So we don't want to freeze it. We are making it to a 0 degree. Okay, we are making it to 0 degree. We are not going below that. We are not going to negative. Okay. For refrigeration systems, room above 32 degree Fahrenheit. Okay. So we are going to design above 32 degree Fahrenheit. Okay. So example, you can draw this. This is the cold storage. For example, you take this as the cold storage, and this is the orientation: north, south, west, east. North, south, west, east, and its dimension is also given: 8 feet width and 8 feet height, 28 feet. So you draw this. This is an example. Don't forget to write the orientation: north, south, west, east, and the width is given as 8, height is 8, this is 8, and this is 28 feet. It's in feet, okay? So kindly draw this, please. Once you draw, let me know, okay? Draw fast, we don't have time. We have to complete one more topic today itself. BOQ, bill of quantity, estimation and quantity, or estimation and cost. What about others? Have you finished writing this? Okay. So north, south, west, east, 8, 8, 8, and 28. Right? Now, so as we have already gone through, we are going to find from where and all the heat is being generated. We know it will be from transmission load will be there, internal equipments will be there, right? And product load will be there. Okay. Here respiration load is not taken because it is not fruits and vegetables, it's a milk. Okay. So you have to leave that. Okay. So we are going to see from where and all the heat is being produced. First, before that, we need to know what is the room dimension. We have to find the volume. Okay. We have to find the volume, and according to the different items that we are going to store, the room temperature will be different. For milk, it can be 35 degree Fahrenheit, but for coming to milk, sorry, for meat, it will be negative. So there is a tabular column according to different materials, different cold storage temperatures will be there. So we have to set the temperatures according to that. Or we have to set the cold storage temperature according to that. We have to calculate according to that. So here, uh, as the we are going to store the milk. So in order to preserve the milk, we have to keep the cold storage in such a way that it should be kept in 35 degree Fahrenheit. We have to set it to that degree. Okay. So first we are going to find the room dimension. So what will be the, can you find the volume, room dimensions, and can you find the volume? Can you give me the answer? What will be the volume? Can you see the volume which is written here? Is it possible to see? Or only I can see, or only or I am not able to see this? Are you able to read this width, length, and height? You can see this. I'm asking, will you able to know the value? I'm not sure. You will be able to see the value. No, you can't see the value. Okay, fine. So just write what is the width, what is the length, and what is the height, and find the volume. And just let me know what is the volume that you are getting. One seven nine two. 1792 feet cube, right? 1792. Let's see. 8 feet width, 28 feet length, 8 feet height, 1792 feet cube. So the ambient temperature, normal ambient temperature, outside temperature will be 95 degrees Fahrenheit, right? So take that as 95 degrees Fahrenheit. So we are reducing its room temperature. We are bringing the cold storage room temperature as 35 degrees Fahrenheit. We are setting to that. So we are going to find its difference. We need to know the difference. So ambient temperature minus room temperature is equal to how much? 60 degree Fahrenheit, correct? 60 degree Fahrenheit. So next thing is the insulations, ceiling, wall, and floor. Okay, this is a given value. Okay, this is a given tabular column only. So the ceiling is 4 inch, and the material is polystyrene. Okay, and the wall thickness is also 4 inch. It is also polystyrene, and the floor is 6 inch concrete. Okay, these are the material that we are using here. Okay, this is the material that we are using here. So write this in ceiling, wall, and floor, and the thickness we can write in inches, and the type or the material that we are using for ceiling, wall, and floor are this. Okay, so first you find out the volume, then find the ambient temperature minus room temperature and find its difference. Then write this insulation. What is the insulation? First we are going to find the transmission load, so that we need to know the inches and its types of material also. Okay. So have you written this? Just its types. For ceiling and wall, same thickness and same material. Okay, so you have completed this, I believe. So I will come to this. Now, first one, product load. So product load, how much is the how much is the weight? How much pounds? 2,000 pounds, right? 2,000 pounds per day of what is our item? Milk, correct? Entering from temperature of 95 degree to how much? 35, correct? And the drop will be 60. So the product load, first one the product load. The product is milk, and the capacity is 2,000. And we have to take that temperature, outside temperature, to the inside room called storage temperature. This 95 degree Fahrenheit to 35 degree Fahrenheit. So we have to, there is a temperature drop of 60 degree Fahrenheit. So we have to bring the temperature to a 60 degree Fahrenheit difference. So first you write product load and write 2000 pounds of milk to be reduced from entering 95 to 35 degree Fahrenheit of temperature. Write fast, okay? Have you written this? Now, I'll come to this, okay? Now write some miscellaneous, okay? Motors. There is a, I am going to give a 0.2 HP inside the room, okay? And the ground temperature is 60 degree, okay? And just give ground temperature 60 degree, and there is a 2.2 HP motor. So an equipment is there inside their cold storage, that is 0.2 HP motor is there, okay? Now the ground temperature is, I am bringing to 60 degree, okay? The ground, the floor. For freezers, it becomes necessary to provide heat in the base slab to avoid freezing of the groundwater of the floor. So you know that, this is a cold storage, okay? It's a cold storage room. So always the water will be accumulated in the floor, okay, because of the cold storage. So what happens is that sometimes if it becomes freezing, what happens? There is a chance of, we may fall down because it's freezing. It can become ice. So what we do is that we will be avoiding its freezing by we will be giving some temperature. We will be giving some temperature to the room. Okay. So for freezers, it becomes necessary to provide heat in the base slab to avoid freezing of the groundwater, okay, of the floor. So minimum slab temperature should be at least 40 degree Fahrenheit. Normally 55 to 60 degree Fahrenheit should be used for freezer application. So minimum it should be 40, and normally 55 to 60 degree Fahrenheit is being usually given to the floor, so in order to avoid freezing of the groundwater. Okay, if there is some freezing, we cannot walk through the floor. Okay, so we should make sure that we should avoid freezing. Okay, so normally you'll be giving 55 to 60 degree Fahrenheit. So here you give ground temperature as 60 degree Fahrenheit. Okay. So there is, we are assuming that there is a 0.2 HP motor inside the room. Okay. Now afterwards, there is a area of the room. You have already found out the volume, length into breadth into height. So what would be the area? Area will be length into breadth, or 28 into 8. Okay. Why we are going to find this area is that we are assuming the light law, lighting. So here we are assuming as 1 watt per feet square. So in our lecture classroom manual, we have already given 1.4 watts per feet square, right? So here we are just assuming as 1 watts per feet square for this lighting inside the cold storage. Okay. So you can see here typical storage requirements are 1 to 1.5 watts per feet square. Cutting or processing rooms can be double the wattage. So if there is some cutting or processing inside the room, inside the cold storage room, so you can even bring it to 2 to 3 watts per feet square. So here, typically it is 1 to 1.5 watts per feet square for lighting. So here we are assuming 1 watts per feet square. If you want to give 1.5, it's up to you. Okay, so here I am assuming as 1 watt per feet square. Okay, these are the input values. Okay, these are given values. Okay, so you know that the square feet is 224 square feet. So we are assuming 1 watts per feet square. So probably how many watts we will be getting? 224 watts because 224 into 1 watt. Okay. So here the number of people we are considering as 0 because people will be coming inside and going outside. So there will be, people won't be permanently inside a cold storage. So we are considering here as 0 number of people. Okay. So you can write this also. These are miscellaneous input values. Kindly write fast, okay? Once you finish this, give me a thumbs up. Okay. Now, what we are going to do is that transmission load. Transmission load. The first one is transmission load. So, you know that the formula of transmission load we know Q is equal to, here what we are going to find is Q is equal to area into heat load. Area into heat load. So, we are going to find the transmission load of ceiling, walls and floor. So, here we are considering all the walls are exposed. So, ceiling, north, south, east, west wall and floor. So, we are going to find the area and its heat load. So, you know what is the area of the ceiling? What is the area of the ceiling? 28 into 8, right? 28 into 8 is the area of the ceiling. So, next, what we are going to find the heat load. Heat load, we can find it from table 1. So, table 1. So, we can see one is table 1. It's table 7. So, table 1. So, you can see here. So, instead, we are going to find about the ceiling, correct? Ceiling. So, ceiling means, you know, what is the inch thickness? 4. What is the material? Okay, polystyrene. So, for finding the heat load, we need to know the thickness and type and the temperature difference. With this 3, we will be going to find out the heat load. We need to know the inches, thickness, its type or material. We need to know the temperature difference. So, let's see. You know, here it is cork or mineral wool, glass, fiber or polystyrene. So, our material is polystyrene, correct? It is not urethane or it is not foam. Okay, so our material, insulation material in inches is polystyrene here. So, what is our inches? How many inches? It's 4 inch, correct? So, it's 4 inch. And what is our temperature difference? Outside minus room temperature, how much? Plus 95 minus 25 plus 60, correct? So, we got the temperature difference. And now we got the material and its inch. Okay. So, what will be our value? 64 will be 87. 87 V2 per 24 hour per square feet. Okay, V2 per 24 per square feet. So, that will be our heat. Okay, that will be our heat load. So, you know what is the material? Polystyrene, its thickness, its temperature difference. By these 3, we will be able to find the heat load. I think it's clear, right? So go to the transmission log and find the answer. Ceiling 28 with 8. Heat load, how much it was? 87, right? 87. So what will be the answer? Just give me the answer of it. Just give me the answer. Answer is 19488. Is it correct? What about others? Are you doing it or just 19488? Okay, I don't have time for everyone. Okay. So it is 19488 BTU per 24 hour. Okay, BTU per 24 hour. The same way, what will be the length and width of the north one? Will be 28 with 8. Heat load, how much it will be? Same. It will be same, right? Because the material is also same, the thickness is also same. Correct. So it will be 87. South wall also 87. Same. East wall also it will be different. East wall will be 8 and 8. Height will be 8 and width also will be 8. So heat load will be same. This is the value. West wall will be the same. And what about the floor? And the floor heat load will be different because its material or its thickness is different. Material and thickness is different. So we can see that also. Okay. What is the material of our floor? 6-inch concrete. Correct. Here on the down last column. 6-inch concrete. 60-degree temperature difference. So heat load will be 300. From here, the heat load will be 300 BTU per 24 hours. Okay. So, complete this also. Once you finish writing this, let me know. Okay, I believe you have written this. Now, now, second one, air change load. Air change load. First one was transmission load. Second one, air change load. So air change load means volume in feet cube into air change factor into outside air factor. Okay, this is the air change load. Uh, Air change load formula. Okay, air change load. So what is our volume? 1792. So air change factor we will be getting from this table, okay, according to the volume. So average air change per 24 hours for storage rooms above 32 degree Fahrenheit or 0 degree Celsius due to door openings and infiltration. Okay. So air change factor we will be getting from table 4. This is the table 4. You could see here two columns here. One is volume in cubic feet of liquid and air change per 24 hours. So what is our volume? 1792. So there are different volumes here: 200, 250, 800, 1000, 1500, 2000. Okay. And according to that, different air changes per 24 hours is also given. For 200 is 44, 250 is 38, 800 is 20, 1000 it is 17.5, 1500 is 14, 2000 it is 12. And according to that, it decreases. Okay. So what is our volume here? 1792. So if it is 1792, it comes in between 1500 and 2000. So it comes almost near to 2000. So you could take this volume cubic feet as 2000. Okay. So and take its value respect to 2000. It is 12. Air change per hour is 12. So what you have to write? You have to write 12 as the air change factor here. Understood? So for 1500 is 40, 1200 is 12. So 1792 is coming closer to 2000. So you take air change as 12. So multiply with 12. And one more thing, into outside air factor. Into outside air factor. Outside air factor means that you will be getting from table 6. So we could see where is table 6. It is the value is 2.49. So we could see what is table 6. This is table 6. Heat removed in cooling air storage rooms. So you could see different storage room temperatures. It is given in degree Fahrenheit as well as in degree Celsius. It is given in 55 degree Fahrenheit in degree Celsius also. It comes to 0. It comes even to negative 30 also. Okay. It gives in degree Fahrenheit and degree Celsius. So temperature of outside air. Outside temperature is also given. So here, what is our outside temperature? This is the outside temperature, right? 95 degree Fahrenheit and what? 35 degrees Celsius. So what is our normal best humidity ratio? Relative humidity, it will be 50%, correct? Normally it will be best will be 50%. So what you have to do is that outside temperature is 95 degree Fahrenheit, choose this one and take the humidity, relative humidity as 50, okay? And our cold storage temperature is how much? What is our cold storage temperature? It will be coming in which range? Coming in 35, correct? Our cold storage room temperature is 35 degree Fahrenheit. So 35 degree Fahrenheit, 95 degree Fahrenheit outside temperature, and 50 to take as average, and you will be getting 2.49 as the heat removed in cooling air storage rooms. Okay. So 2.49 B2 per cubic feet. So you can write it 2.49 as the outside air factor from table 6. So when you are multiplying all these things, you will be getting 53545 B2 per hour. B2 per 24 hour. Okay. So you'll be getting this value from table 6 and this value from table 4. This from table 6 and this from table 4. Completed? You are taking this much time. Completed this one? No, no, you don't want to note this table. Don't note down this table. This table will be already given only. Okay. Okay. All the tables will be given. Okay. All the tables and graphs will be given. You just need to write only this. Okay. Now, now coming to additional loss. So we know that we have already given as 0.2 HP. So to convert this point HP into BTU per HP per 24 hour, multiply with the 75,000 BTU. Okay. So we have an electric motor of zero point 0.2 and like electrical lights. How many watts we have calculated? 1 watt per feet square. How much it was? 224. Correct. Because our area was 224, we have given 1 watt per feet square, so it will be 224. And multiply with 82, you will be getting the value in BTU per 24 hours. Okay. So each watt is multiplied by 3.42 to get BTU per watt. To take BTU per hour figure, this again should be multiplied with 24. So 3.4 into 24 is already 80. Okay. Directly they have written this. So in order to convert this watts into BTU per 24 hour, just multiply it with 8 to 3.4 into 24. And you'll be getting 50,000. Here you'll be getting 1,8, correct? 1,8368, correct? People load is 0. Number of people is 0. So leave it, okay? If occupancy load is not known, one person per 24 for each 25,000 feet cube space. So for each 25,000, you could calculate as one person also. One person per 24. So here if it is 1, you have to multiply with BTU per 24 hours. So BTU per 24 hours you will be getting from here. Heat equivalent per person. Okay. So our cooler temperature is 35. It comes between 30 and 40. So you take the average value of this and you just give it here and multiply with the people load and you will be getting the value. Okay. So if the occupancy load or the number of people is not given, if we can assume one person for each 25,000 feet cube space. We don't have 25,000 feet cube space. So anyway, the people load is 0 here. And multiply with BTU per 24 hour. The value will be taken from, we can take the value from here according to the cooler temperature. So once you finish this, let me know. Write fast, okay? This is easy one. You just go through all the loads, okay? You just go through all different parameters from where and all this heat is being generated, like additional loads, people load or transmission load, okay? All those things. And get its value and take its value from the tabular column and just input it and find out the value. That's it. Write fast, please. Okay. I believe others also have finished writing this. Now, product sensible load. Here we are dealing with only sensible load because there is no phase transformation. So write product load or sensible load. Okay, product sensible load. Step 4. So how much pounds of milk per day? was 2000, right? And we have to multiply with specific heat. Okay, we have to multiply with specific heat or sensible heat, whatever it may be. We have to multiply with specific heat. So we have to multiply with specific heat means we have to take the value from table 7. So where is table 7? 6. Where is table 7? This is table 7, correct? So here storage requirements and properties of perishable foods products is given. So here the commodity is already given. There are I have taken the screenshot of only this. Okay, there are n number of items here. Okay, according to the alphabetic order. So here what we have taken is that our material is milk, right? So the milk is already given here. So in this milk there are subdivisions: pasteurized, grade A, condensed, sweet, evaporated. So here we are choosing pasteurized grade A. And what is our storage condition? What is our storage temperature? It was 35, correct? So it is coming in, we could take this 32 to 34. Then the next one is 40 degrees. So what we have to do? Take this temperature, 32 to 34. Okay, actually it is 34. We have just assume it as and give it as 35. That's all. So here you have to take milk, then choose this pasteurized grade A milk. The storage temperature we already know it is 35. So you could take this one. Okay, its approximate storage life is 2 to 4 months. Okay, and the highest freezing point is 31 degree Fahrenheit. Let me leave it. Now there is specific heat above freezing, specific heat below freezing, latent heat of fusion, product law density approximation. Let's you leave it. So here, what we need to take: specific heat above freezing or specific heat below freezing we have to take, or latent heat we have to take. Here we don't want to take latent heat because there is no change in the phase. So leave this one. Now we are now dealing with specific heat, correct? Or we could call it as sensible heat also. So the specific heat below freezing. Are we bringing the milk below freezing? Below 0 degrees Celsius? Are we bringing it? No, right? So we can cancel this also. Specific heat below freezing. We are not freezing it. We are just cooling only. So what we have to give? Specific heat above freezing. It should be above freezing. We are just cooling only. We are not freezing it. But the thing that we are taking place is specific heat. Okay. So what is the value? What is the value for specific heat? It's not given. It is 0.93, correct? It is 0.93, correct? So I'll say once more. Commodity is milk. Temperature is 32 to 34. The specific heat above freezing. So the value is 0.93 BTU per pounds per degree Fahrenheit. 0.93. So it is 0.93. So we just write 0.93 from table 7 into temperature difference you already know 60, and you will be getting the value. Okay. So write this one. Product law. Completed? Yeah. Now, okay, this 0.93, right? Now coming to the product load, respiration. So here we don't want to take this respiration into account, okay? Because we need to deal with only, you know, uh, here I have already said that the respiration load is taken place in fruits and vegetables, because that fruits and vegetables is a live thing. It's a live thing. Okay. So because it's a live thing, we need to keep it in mind that it is we need only uh, in case of vegetables and fruits only, we have to take care of this respiration load. In milk we don't want, so you can skip this. So if at all, if there was vegetables, okay, you need to write its pounds and you have to multiply it with its heat, BTU per pounds per BTU per pounds per 24 hours. That you will be getting from table 8. So this is the table 8. So these are the different products: apples, cherries, grapes, everything is given here. So according to the temperature, you could take this value, okay, and you could give it here. You could give it here. You could give it here and you could get the value. So here you just skip it off. So anyway, you write product dot respiration and write this formula, and you write one more thing: only used in fruits and vegetables cold storage. Only used in fruits and vegetables cold storage. It is not considered here. Write this heading, product lot respiration, and write this formula, and write one more note: only used in fruits and vegetable cold storage. It is not considered here. Right? It is used in fruits and vegetable cold storage. It is not considered here. Write fast, or write any one formula, okay? Now what we have to do is that total refrigeration load, you have to add all these things. 1 plus 2 plus 3 plus 4 plus 5, all the 5 steps. You add all the 5 steps, and I think you'll be getting this value 5313 it seems. Okay, 335313 BTU per 24 hours. And here also you have to add a 10% safety factor. As a safety factor, you have to add 10%. So you'll be getting 33531. 10% of this value is this one. Then you add this both. Okay. So you'll be getting approximately 368845. So this is our total BTU per 24 hours for this cold storage. Okay. And the last thing that you have to keep it in mind is that the hourly heat load. So this what do you mean by this is the hourly heat load serves as the guide in selecting the equipment. It is found by dividing the final BTU per 24-hour load by the desired condensing unit runtime. So everything we won't be continuously running for 24 hours according to different temperatures, temperature rooms and cold storage and equipments. They will be reducing the time. Sometimes we'll be running the cold storage for 16 hours, sometimes 18 hours, sometimes 20 hours, sometimes 20 to 22 hours. So here it is a 35-degree rooms with no timer. We are assuming it 35-degree Fahrenheit rooms. We are cooling rooms with no timer. The running hour, okay, or the run time of the cold storage, we are taking it as 16 hours. So what you have to do is that you have to divide the number of operating hours by 16 to get BTU per hour. So this is BTU per 24 hour. So in order to get the BTU per hour, how much BTU is being produced from a single hour, you have to multiply by 6, or you have to divide by 60, because the running time is only 60. Okay, so the running time is only 60. So you have to write divide the above value by number of operating hours to obtain BTU per hour. So in this case, the operating hour is 16. So the cooling requirement, so load cooling requirements will be this value with divided by 16. You will be getting this value. You divide this value with 16, you might be getting 23053. And let me know whether this answer is correct or not. Kindly write fast and let me know if this answer is correct. It's correct. Okay, fine. So this is our BTU per hour. So do one more thing. Just convert this BTU per hour to ton. You know, one BTU, one ton is equal to how much BTU, you know it. So kindly find out the ton of this, how much ton capacity, and find out the answer also. So right, to calculate the tonnage value, right, one ton is equal to this much value, and find its capacity ton. You're getting 1.92 ton, right? What about others? You'll be getting almost 2 ton. So one TR is equal to 12,000 BTU per hour. So 23,053 BTU per hour will be almost 2 ton, correct? 1.92. So write that also. 1 TR equal to 12,000 BTU per hour. So I think you have written this, okay? Is there any doubt? What's the ton value? We're getting 1.92 ton. Just divide by 12, 12,000. We'll be getting this. Okay, anyways, the answer is 1.92 ton. So I'm just skipping this. This is enough. So this is the way that you will be finding out the capacity. Okay. And now we are moving to the next topic, estimation and costing. So write the heading estimation and costing. Estimation and costing. So what do you mean by estimation and costing is that when we do a project, we need to know the bill of quantity. We need to know the quantities, how much, uh, for example, if there is a air conditioner, what is the capacity of it? Okay, how much it cost? Okay, then if you have duct, okay, what is the area of the duct? Okay, that will be hanged by hangers. Okay, okay, we should be able to know the duct support. Okay, how much duct support are there? Then flexible connections, number of fittings, okay, elbows and all those things. Then insulation, acoustic insulation, thermal insulation. What is its quantity? Okay, how much is its cost? And we have to calculate all the areas, all the dimensions how the quantities we have to find it out, and then we have to find the approximate cost for individual material, and we have to give the approximate cost also. And finally, we have to give this to the client. Okay, so that is also coming under the HVAC engineer. Okay, you have to do it. You have to calculate the estimate as well as the quantity, bill of quantity. You have to find the estimate cost of it, and we have to give it to the client. Okay, so that is also involved in it. So write the heading estimation and costing, and we are going to do a question. Okay, we are going to solve a question. How we are going to solve a question is that here I am going to give an FCU or a fan coil unit. From there I am going to show a duct of some length, and I will show you some branch ducts, and I will show you the air terminals. Okay, and we are going to see what is its dimension, how much is its length, and we are going to find out its approximate cost also. Okay, so I will show you my notes, that will be better. Okay, so can you see this? This is estimation and costing, and I'll just explain this. What is this? Okay, don't skip anything. Okay, from here, this is the FCU, fan coil unit, and there is a strainer inside it, or a filter you could call it, and there is a blower inside this. Then it goes through a flexible connection. The flexible connection, you know it. The duct which is connected to the indoor unit is been connected by a flexible unit. So this is flexible unit. So already it has been written here. Okay, you can see 1, 2, 3, 4, 5, 6, 7, and where is 8? 8, 9, 10, 11. Okay, and all these things has been written down. Okay, one is strainer, second is 2 is blower, third is canvas connection, fourth is reducer, fifth one is straight duct, sixth one is elbow, seventh one is shoe neck, eighth one is volume control damper, ninth one is flexible duct, 10th one is plenum box, 11th one is supply and return linear bar grill. Okay, it's already written here, so don't skip any numbers. Okay, so this is strainer 1, 2, 3. You can see another one thing: A, B, C, D, E, F, G. Okay, you can see that H. Okay, you can see that. So the air has been passing through the flexible connection, comes to the reducer. The reducer width is 0.75 meter. Okay, or you could write 750 mm. And its dimension of the big side is 100 into 30 centimeters. 30 centimeter height and 100 centimeter width. Here 65 centimeter width and 30 centimeter height. Okay, so yeah. Now it is going through the elbow. It has been spreaded into 3 different flexible branch duct, and this is a 10th one is the plenum box, and it goes through the grill. Here this 3 tier, here this 2 tier. Okay, again here reducer, duct, elbow, here duct divided into 2, and goes to the plenum box and goes to the grill. Okay, so this is 65 to 30 centimeter. This one, this is also 65 to 30 centimeter. This is 45 into 30 centimeter. Okay, this length is 2 meter. This is 0.75 meter. This is 4 meter. Okay, not 4 centimeter. It is 4 meter. Don't write as 4 centimeter. It is 4 meter. Okay. So do one thing. Draw this. Don't skip anything. Okay. Draw this. FCU, strainer, blower, flexible connection. A is the reducer, B is the straight duct, C is the elbow, D is the straight duct. This is shoe neck, 7th one shoe neck. Then this is a 3 meter length plenum box. Then it comes to the air terminal grill. And again from the side, reduce the F length duct, G is the elbow, H is the straight duct. Again, it is being subdivided into two, and this is grill, sorry, plenum box, then grill. Here 2 TR is going, here 3 TR is being passed. This length is 4 meter, this length is 0.75 meter, this length is 2 meter, this length is 5 meter, this length is 0.75 meter, this length is 5 meter. This is 100 into 30 centimeter, this side. This is 65 into 30 centimeter. Once you finish writing this, let me know. How fast pace? Have you drawn this? Okay, then try this also. So if you are wrong, okay, just show me, okay. So first one is trainer, second one is blower, third one is canvas connection, fourth one is reducer, fifth one is straight duct, elbow, shoe nut, ECD, flexible duct, cleanup box. Okay. This you write from the, you look it from the video that I'll be sending you, and you could write this down, okay. So right now you just leave that page, this much. Okay, you could copy it from the video, okay, that I'll be sending, recorded video. Now, next one is, leave that. The recommended metal gauges. The recommended metal gauges. Okay. So just listen here. Okay, that's enough. This is the given. Okay. This I think we have already gone through this thing before itself during the duct sizing. Okay, I have shown this. And recommended metal gauges. Gauges means that already it's the thickness, correct? So here it is the greatest dimension. In inches is given and in centimeter is also given in this column. Its gauges is given, thickness is given, nominal weight is given in kilogram per meter square. So in inches, if the greatest dimension is less than 12 inch or 30 centimeter, the gauge will be, or the thickness will be 26. In mm, you could call it as 0.4. And its normal weight will be, of that sheet will be 4.42 kilogram per meter square. Okay. If the greatest dimension is between 12 inch to 30 inch or 31 to 76.2 centimeter, the gauge will be 24 or the thickness should be 0.6 and the weight will be 5.64 kilogram per meter square. So the greatest dimension means, for example, if the duct dimension is 100 into 50, okay, 100 width and 50 height, the greatest dimension is 100. For example, if the duct size is 500 into 300, the greatest dimension there is 500. Understood what I am saying? So here the greatest dimension, here this in inches as well as in centimeter is given. It is less than 12 inch or it is less than 300 mm or 30 centimeter. The gauge or the thickness you could take it as only 0.4 is enough or 26 gauge is enough. So see this different range, 31 inch to 60 inch or 79 centimeter to 152 centimeter. It is 22 gauge. So when you are designing a project, okay, there will be different sizes of ducts, 500 to 300, 600 into 400, 1000 into 800, and you have to see when you are coming to BOQ, bill of quality or estimation and costing, you have to see the dimensions which comes under this range. You have to see the dimensions which comes under this range, and you have to choose the gauge also. You have to choose the gauge. So when you are writing the bill of quantity, this much area or this much amount of duct of 22 gauge. Okay, then you have to write this much square meter, okay, of GA duct of 26 gauge. You have to write that also, okay, because the thickness of different dimensions is different. Okay, so if it is greater than 91 inch or greater than 231 centimeter, the gauge should be 18 or the thickness is 1.2 mm and the weight will be also large, 10.5. So you don't want to write this, you can copy it, okay, because due to the lack of time, you can copy it from the recorded video, because there are many more people also who are seeing the recorded videos. Only few of them are just coming to this classroom, but there are still other people who just see only the recorded videos because of their job or something like that. Right? Now, the next one is, this is the important thing, okay? What we are going to do is that we are going to find out the total weight or the total amount of material that we are using in our project. Our project means we are taking only a small portion of this. This is our portion. So we are going to see how much amount of quantity of ducts are there and how many grills are there, how many elbows are there. Okay, all those things we are going to find it out. How much quantity of the acoustic lining is there, thermal insulation is there. Okay, so what you have to do is You have to write it. Okay, you have to write this down. Okay. Uh, Not now, not now. You got copied from the uh, recorded video. So here is the node A, B and D, C, E, F and H, G. This node A, B and D, C, D, E and F, H and G is this one. You can see here A. This is the node A, that reducer. B, straight duct. C, elbow. D, again straight duct. E, elbow, reducer. F, straight duct. G, elbow. H, what is that? Straight duct. Okay. All these things are given there. So node, in the first column, node. Second, duct size. Third one, duct length. Then perimeter in centimeter. Then area in meter square. Then nominal weight. Then total weight. Then acoustic line. Okay. So first we are going to see about node A. Node A means what is node A? Node A is a reducer. You know it. Node A is a reducer. It's one side, like height and width is 100 into 30 centimeter. The other side is, you know, already it will be 65 into 30. Correct? 65 into 30 will be this side, and 100 into 30 will be this side. And node A is a reducer. Okay. So let's see. What is the duct size? One side is 100 to 30. It's a reducer. That's why two different size. The other side is 65 to 30. What is its length? It is already given 0.75 meter or 750 mm. So that length is shown in, is asked in meters. So it is 0.75. What is the perimeter? Perimeter means you have to add all the sides. Okay, add all the sides. 100 plus 30 plus 65 plus 30. So you'll be getting 225 centimeter. So you got the perimeter. So how to find the area? If you got the area, the formula is perimeter into length is the area. But we already know it's a simple max. So you got the perimeter in centimeter. So to convert into meter, it is 2.25. And the length you already know, it is 0.75. So perimeter into length, 2.25 meter into 0.75 meter, it is 1.68 meter is the area. So the next column it is shown. What is the nominal weight? What is the nominal weight or normal weight? Whatever name. Is written as 6.86 kilogram per meter square. How to find? How to know that this is 6.86? So you have another listing, right? Another tabular column. What is the tabular column? Recommended metal gauges. So here it is given nominal weight. So here, according to the latest dimension, we have to find the nominal weight. Correct? So here it is given us what is the largest duct length or the duct size? 100 into 30 and 65 into 30. What is it? 100. Correct? 100 is the largest duct length or the size. So we are going to see in which range this 100 will be coming. So 30 centimeter, 31 to 76, 79 to 150. In this range, 100 centimeter will be coming, right? The largest duct dimension or the greatest dimension is 100. So it will be coming in this range. So what will be the nominal weight? 6.86, right? So right there, 6.86. Now total weight will be nominal weight into area. So this is total weight. So multiply this with this, we'll be getting the total area. Now, what about the acoustic line? So you know that the acoustic or the sound insulation we'll be giving for the first 3 meters. So anyways, this first one is directly, anyways, this reducer will be already, occupied in that, which means that we are looking for first 3 meters only insulation. But anyway, as this reducer is coming initially after this flexible connection, anyway, this will cover up. Anyway, this will cover up, right? So all this area will be covered with sound insulation or acoustic insulation or lining. So what you have to do? This area 1.68 area will be covered with acoustic insulation. So you give the same area of the duct as the acoustic insulation area also. You understood what I'm saying? So that dimension of the reducer, node is A, it is a reducer. The dimension is 100 into 30 and 65 into 30. The duct length is 0.75. Perimeter, you have to add all those sides. Area means perimeter into length. Perimeter into length, you multiply and get the answer. Nominal weight, you go to the other this thing and find the largest dimension. And here the largest dimension is 100. That will be coming in between this range. So you find the appropriate nominal weight, that is 6.86, and give it here 6.86. Then multiply this 6.86 with the area, and you will be getting the total weight. Then give the acoustic lining. So acoustic lining, we know all the area of the reducer will be involved in acoustic lining. So give the same area here also. Okay. The same way, the second one is B and D. What is B and D? B and D is a straight duct having same dimension, 65 to 30. Here also 65 to 30. Its length is 5 meter. Here it is 4 meter, not centimeter, meter. 4 meter. Okay, you understood that? So duct size 65 to 30. B and D. So duct length will be 5 plus 4. Okay, 9 meter. So what will be the perimeter of the duct? It is 2 into length plus breadth. That is a formula, or that is a formula of the perimeter. 2 into length plus breadth. What is the length? 65. What is the breadth? 30. So 2 into L plus B is equal to 190 centimeter, which means 1.9 meter. So area will be perimeter into length. So 9 into 1.9, 17.1. So nominal weight. So nominal weight means we need to see what is the largest duct dimension. So here 65 to 30, 65 is the largest duct dimension. So 65 into 30, it comes in between 31. Do we need to increase the size of duct, which is acoustic line? No problem. Do we need to increase the size of the duct, which is acoustic line? Area will decrease, yeah. But actually, when we are sizing it, we'll be giving only the approximate. If it is 225 into 250, okay? It is 225 into 250, 250 into 250. We'll be rounding it and we'll be giving. So, for the first 3 meters only, na. So it will be already. It will be you'll be getting the sufficient area. No problem. Sufficient area. If at all it is something is less, the noise criteria will be little more bigger, or the friction loss will be little more bigger. That's enough. That's all. So no problem. If you can increase the size, better. If you didn't increase also, it's not a big deal. Okay, it's not an issue. But better if you can increase, it's not a problem. But normally, we'll be giving the round off value, so it will be already accompanying that lost area. Okay. So 65 into 30 will be coming between 31 to 76.2 centimeters. So the nominal weight will be 5.64. 5.64. So you write nominal weight 5.64 here. Nominal weight into area. Okay, that is a total. So you just multiply. The same way we have did it for the first column, first row. So the acoustic lining, I have already said that it is for the first 3 meters. What you have to do? Just multiply this perimeter area. Okay, perimeter area into this length, 3 meters. The first 3 meters. So you just multiply with 3. Perimeter into, don't multiply with the total length. So you'll be getting the total area. We have to just multiply with only with 3. Why? Because we are giving the acoustic lining only for the first 3 meters. So just perimeter into 3, you will be getting its area. Okay. Now C. C is, what is C? C is, C is elbow. So we have to take care of that. C is elbow. So in the case of elbow, what is the size of the elbow? It is 65 into 30, right? This is 65 into 30. This is also 65 into 30. The elbow size is 65 into 30. That you know. Do you know the length of it? Do you know the length of this elbow? No, we don't know. We have to find the length of the elbow. Okay. So in order to find the length of the elbow, we have a formula. Length of the elbow is equal to L equal to R plus W, radius plus width. So initially, before 2-3 days, I have already given you how the duct fitting calculation, duct fitting, how to draw the elbow with the dimension. I have already shown elbow, reducer, shoe neck. I have already asked you to write it in the notebook, and I have already given. So I have already said that if it is a small elbow, okay, when you are choosing the radius, you give half of the width. If it's a medium, you give the same as that of the width. If it's a larger duct, you give 1.5 times of the width for the radius. So here we are choosing as a small duct only, small duct area. So what you have to do is that this is the formula for finding the length of the elbow. L is equal to R plus W. R is the radius, W is the width. So we know the radius of the elbow is equal to, here we are choosing it as 0.5 of the width. Okay. So insert this 0.5 W as R. Okay. So 0.5 W means width you already know, it is 65. 65 is the width of this elbow. 65 is the width of the elbow. So 65 into 0.5 is the radius. So that is 32.5 centimeter. You understood that? So here what we are going to do is this. R is equal to 0.5 of W. Half of it. Width you already know, 65. So just multiply 65 with 0.5, we'll be getting 32.5. So include this 32.5 in this. So you'll be getting 32.5 plus W. W you already know it is 65. So plus 65. You'll be getting L as 97.5 centimeter. Once more I will explain. L is equal to R plus W. R is equal to 0.5 of W. W you know 65. So you'll be getting R as 32.5. Equate this 32.5 in this equation. So 32.5 W plus W or 32.5 plus W. So 32.5 plus W is equal to already 65. So you'll be getting 97.5 as the length, the actual length. Now to find the equivalent length, we have already know that the equivalent length will be the double of the actual length, right? That we have seen before itself. So what you have to do? 2 times of this length will be the equivalent length. So multiply 2 with 97.5, we will be getting 195 centimeter. So 1.95 meter is the length or equivalent length of the elbow. So right, 1.95, and the perimeter is same formula, 2 into L plus W or L plus breadth. So 2 into L plus W, then the same way, area is equal to 1.9 into duct length. Nominal weight, the same way you find it out. The total weight, you multiply this with this, you'll be getting this answer. Acoustic tiling you don't want, because only for the first 3 meters we are looking. So here you just leave it out. The same way, what is E? What is E and F? What is E? What is not E? Not E is the reducer. So do the same step as that of A. Okay, do the same step as that of A. So you'll be getting the answer like this. What is F and H? F and H. It is duct. 45 to 30, 45. Do similarly according to this D and D. So that is also duct. D and D. It's the same way you do it for F and H also. Now G. What is G? G is the elbow. The same way you have done for C, you do it for G also. Okay. So G, the length duct with dimension is 45 into 30. You know it. This 45 into 30. 45 into 30. 45 into 30. This G. Now we are going to find the duct length. The same formula. L is equal to R plus W. R equal to 0.5 into W. W is equal to 45 here. So 0.5 into 45 is equal to 22.5. 22.5 plus W equal to 45. 22.5 plus 45 equal to 67.5. That is the actual length. Equivalent length will be the double of the actual length. So 67.5 into 2 is equal to 135 centimeter, which means 13.5 or 1.35 meter. Okay. So give that 1.35 meter here. So the perimeter, same formula, 2 into L plus W. Area, perimeter into length, you will get this. Nominal weight, you will get from the other tabular column. And total weight, this nominal weight into area, you will be getting the total weight. So this is the method we have to find out the values. Okay, you go through the video and you just find it out and see whether you are getting this answer. Next, this is the estimation. Okay, so what you have to do is that you have to add all these values. 11.5 plus 96.44 plus all these values, and you have to add it here. Acoustic lining also, you have to add all these values and you have to add it here. Okay, so whenever we are doing all these things, we should be given we should do a safety factor. You have to give an allowance. So you should not give a correct amount. You should add some safety factor to that also. Okay, so what we have to do is that you have to add all those things. Okay, total duct length you have to add. So here you have to add the total duct length. 0.75 plus 9 plus 1.95 plus all this add it here, and you will be getting 20.8. Total area you have to add. Total area, what is the total area? Total area, how much is the total area? Total area, how much? You have to add all these values. So what you have to do, you have to add all the duct length, add all the area, add all the total weight, add all the acoustic lining also. So you'll be getting these values. Total area is 36.3, total weight is 206.72, total acoustic lining is 7.38 meters square. So you'll be getting all these values. Then what you have to do is that you have to give an allowance or a safety factor. You have to give 20% in duct weight, 15% in insulation, thermal insulation, and 10% in acoustic lining. So what you have to do? Duct weight 20%. What is our duct weight? Total duct weight 206.72. So add a 20% to it. How will be adding 20%? Multiply with 1.2. So you'll be getting this much value. Duct insulation add 15%. So duct area into 1.15, 15%. You'll be getting this value. Acoustic lining, what do you have to do? Multiply the acoustic total area into its add with at 10%. So multiply with 1.1, you'll be getting this value. Okay, so you got all the values, all the duct weight, insulation area, and acoustic lining, including the allowance or including the safety factor. So estimation is over. So we have to find the cost. So cost will be changing according to different market. So today will be for this week we'll be having a cost. So the next week that cost will be changed. So you have to update according to the market change. Okay, you have to be updated. What should be the cost or what will be the cost of different materials? You should be updated. So according to that only you'll be giving it here. So estimation is over. Now we are going for costing. So cost of GA duct. So here it is given in 16 SR per kg. SR means it is not in Indian rupees. I have given here. It is in Saudi Riyal. According to different countries, it will change, right? Different currency. So here I have just chosen as Saudi Riyal, okay, not Indian rupees. So cost of a GA duct is 16 Saudi Riyal per kilogram. This is an old, rate may change right now, okay? So 16 Saudi Riyal per kilogram. So what is our total kilogram for the duct, including allowance? Duct weight is 248.064. So 248.064 into 16. So you'll be getting 3969 Saudi Riyal. That is the cost of the duct. Cost of plenum box. So what is plenum box? Cost of plenum box, it is 110 Saudi Riyal per meter. So what is the length of the plenum box? It is written here, plenum box. Which is plenum box? 10th one is the plenum box. 10th one. So here, which is the plenum box? This one is the plenum box. Its meter is 3 meters length. Here another one plenum box is given 2 meter. So 3 plus 2, total length is 5 meter. So plenum box length is 3 plus 2, 5 meter into 110 Saudi Riyal. So 550 is the cost of plenum box. Installation of plenum box 10 Saudi Riyal plus per meter. So you know the total length is 5. So 5 into 10. Okay, it is 50 Saudi Riyal installation. SLBG cost. What do you mean by SLBG? Supplied in a bar green. It is 100 Saudi Riyal per meter. So you can see SLBG. SLBG and RLBG, supply and return linear bar grill. This 11 to 1. So you can see this is the 11 to 1. This is 3 meter, this is 2 meter. Okay, you could take like that. So supply linear bar grill. It is 100 per meter. So what will be the total length? 5. Correct? 3 plus 2, 5 into 100. We are getting 500 Saudi Riyal. Now flexible duct with VCD is 35 Saudi Riyal for one duct. Okay, 35 Saudi Riyal for one duct. There are flexible duct with VCD. So we can see where is VCD. Where is VCD? Where is VCD? Flexible duct with VCD 8 and 9. You can see this is the flexible. This is the VCD. Then this is the flexible duct 8 and 9. So how many flexible duct with VCD is there? 1, 2, 3, 4, 5. So just see that and just give its value. That's it. So flexible duct with VCD is 35 as for one duct. So 5 ducts are there. 35 into 5, 175 Saudi Arabia. Now duct support. You know the duct will be placed there and you have to support the duct. You have to hang the duct. Okay. So every 2 meters, it is recommended that every 2 meters you have to hang a hanger. All right. Duct support you need duct support after every 2 meters. So it is given us 16 Saudi Riyal for one. For one duct support. So this duct support consists of a. This is not fixer. This is fissure of a fissure. 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 There will be a thread drawn, there will be an angle, okay, like this. Then only that will be completely known as a duct support. We will be having an angle, we will be having a rod, okay. We will be having a fissure which helps to fix it on the concrete or on the roof, okay. So recommended that angles are provided at every 2 meters. So don't forget this. So when you are doing a project, you have to give an angle also after each 2 meters. Okay, so total duct length is how much? 20.8. So we are going to find how much is the duct support. So in order to find the duct support, we have to know what is the duct length. What is the duct length? How much is the duct length? You know that the total duct length is 20.8 meter. We have already found out. So we know that for every 2 meters, we have to give a support. So how much will be the support? How many numbers of support will be there? 20.8 divided by 2. Correct? We'll be getting almost 10.4, which means that 11 duct support is there. So 11 duct support for duct. Not only that, we have to give duct support for FCU, fan coil unit. So you give 2 duct support for the indoor unit. Okay. Angles in plenum box, you give 4. Because there are 2 plenum boxes, you give 2 each. So total 4 for the plenum box. Then flexible duct plus VCD, there are 5 ducts, give 1 angle each or 1 duct support each. So 5 duct support are there. So total how much will be there? Flexible duct plus VCD, 5 ducts are there, 5 duct supports are there, 5 plus angle in plenum box 4, 5 plus 4 9, angle in FCU 11, 9 plus 2 11, then 4 duct is 11. So 11 plus 11 22. The total 22 angles are there. So each duct angles or each duct support, which is cost is 16 Saudi Riyal. So 16 into 22 is equal to 352 Saudi Riyal. Okay. Now coming to the outside insulation. Outside insulation means it is thermal insulation. Okay. And inside insulation will be acoustic insulation. We have already studied that. So when you are going to buy an insulation, thermal insulation or acoustic insulation, you will be getting in roll only. You will be getting it in a roll. You will be getting it in a roll, one roll, two roll like that. So one roll, it costs 130 Saudi Riyal for a thermal insulation. So one roll means the dimensions will be 12 meter into 1.2 meter. 12 meter length and 1.2 meter width is one roll. Okay. So we are going to see how much is our total acoustic, total thermal insulation. So our total thermal insulation was this acoustic 41.75 meters square, right? Insulation area. And acoustic it was 8.11 meter, correct? Including the allowance. So the total was 41.74. So the area of one roll will be how much? You know, the dimension of one roll is 12 meter into 1.2 meter. So the area of one roll will be 12 into 1.2. That will be 14.4 meters square. So our total area is 41.74 meters square. So how many rolls will be? You will need how many rolls? 41.74 divided by this area. 12 into 1.2, 14.4. So you need 3 rolls. So you need 3 rolls of thermal insulation. So one roll cost is 130 Saudi Riyal. So 3 rolls it is 3 into 130. That is 390 Saudi Riyal. I'll explain this once more. One roll cost 130. Its dimension is 12 meter into 1.2 meter. One roll dimension. So our total area is total insulation area is 41.74. So we are going to find how many rolls we need. So to need to know how many rolls we need, we just divide this total area with this roll dimension. So we'll be getting 3 rolls. So for one roll it is 130. So for 3 rolls it is 390 Saudi Riyal. The same way you find it for acoustic dimension also. Acoustic lining, one sheet of glass wool. Glass wool is the material that we are used here for acoustic lining. It's 18 Saudi Riyal. Here the dimension is 1.2 into 1 meter is the one roll. When it comes to acoustic lining. So the area will be 1.2 into 1 is equal to 1.2 meters square. So 1.2 meters square, it costs 18 Saudi Riyal. Okay. So total area is 8.1 meters square, right? 8.1 meters square we know. From where we got 8.1 meters square? Here. Total acoustic lining, 8.1 meters square. We have already calculated. So number of rolls will be the same method. 8.1 divided by 1.2. You'll be getting 7 rolls. So one roll 18. So 7 rolls, 126 Saudi. So this is the way that we'll be finding the estimation for each material. Then we will be adding all these things and we'll be getting the estimation. Okay. So this is the estimation and costing. So you can go to your video that I will be sending you again. And I think this is a simple thing. First you have to calculate its area, amount, then give its allowance. Okay, then add all those values. Then estimation. Sorry, cost. For each material, this much amount. According to that, you give value and find it out and get the total value. Okay. So today we have completed estimation and costing as well as cost storage design. Okay. So let's go through it. Okay. We have Excel sheet for estimation. Estimation in the sense, normally what they do is that in actual project we'll be having Excel sheet. We'll be having Excel sheet. In that Excel sheet only we'll be doing it. Estimation we don't have. Estimation in the sense we have to write the amount. Then we have to write the amount for each material and you have to write its estimation according to the different amount. Okay. So I will show you the Excel sheet when we will be dealing with the project. Okay, I will show how we are doing in the actual real case. We'll be having BOQ as an Excel sheet. So I will show you that also. Okay. When we come to the project, I will show you that. Okay. So today we can wind up. So the recorded videos will be already sending to you. So just go through it, and if you want to note down these values and these tabular columns, you just look it on the uh, video and you just note it down. Okay. So thank you, students. Thank you so much. It's already 12:10. Okay. So thank you. Thank you so much.